Okay, section 6.2 continued again, middle of that fraction example and got cut off. So now we need to take the 3 halves that x is equal to and put it back into an original equation. So I'm actually going to put it into this first original one. You can actually put it into the cleared ones, but I don't recommend that in a general practice. Because if you messed up excuse me, clearing them, then it's going to be messed up there, mess up the entire answer. But putting them in with fractions can be really messy too, so I don't blame you if you are hesitant with that, and you can go ahead and put it into the cleared one. So I'm just going to show you that it's absolutely possible to do this. And remind you, and going up here, that if I have 3 halves, and it says that it's divided by 2, that means that I have 3 halves times 1 half. And what you need to remember is that when you have a fraction in the numerator, the denominator comes down into the denominator. And if you have a fraction in the denominator comes up into the numerator. And it always works that way. So this becomes 3/4. And so now what we have is that we have 3/4 minus this is equal to 0. So I'm going to go ahead and I'm going to add 1/4 y to both sides. And so now what I have is I have 3/4 is equal to 1/4 y. And then I'm going to multiply by the reciprocal of the numeric coefficient, and I'm going to finish solving this. So numeric coefficient's reciprocal is 4, and I'm going to multiply by 4 here, and then I'm going to cancel, and I'm going to cancel, and what I end up with is that y is equal to 3. So now I have the y, and I'm going to come up here at the top. Sorry, I'm very messy on one page, huh? And I'm going to write my ordered pair. X is equal to this fraction, 3 halves, and y is equal to, y is equal to 3, not 4. Y is equal to 3. And then you can always check and see if it is the correct answer. And I am going to have you right now go ahead and solve this one on your own, and then you can come back and see if you did it correctly. Okay, so you see that I've solved the second equation for the y because, again, the numeric coefficient of this y is 1, so it'll make it easy to solve for. Now I'm going to take this expression for y and I'm going to put it back into the other equation here. So I'm going to pause it again. You see how it goes for you, and then you can come and check because I'm going to finish the answer before you come back and see it again. Okay, so you substituted this expression that's y into y here in the first equation. Remember the first equation. Simplify it down, and you should have come out with x equals -2. Now, see if you guess what the next step is, and then come back and check and see if you get the right answer for y, because that's where we're going next. Okay, now I've done it both ways that you can possibly do it, meaning that you can put it back into either equation. So I did it in the first equation in blue and the second equation in red. And notice that either way, the answer is the same. It will be. You have the choice of which equation to put it into, and it's one or the other. You do not have to do both. And finally, once I have all of them, right, my step number 4 is to write the ordered pair solution. So my x was equal to -2, and my y is equal to -1. And now I have my solution. So that is the your turn problem. Hopefully you were successful at that, and that wraps up section 6.2. So we'll be coming back in the next lecture and doing section 6.3. That's a new method again.